Good morning, children. How are you? Hope you are doing well. Have you studied the previous class notes? In the first class, we have started our chapter electricity. In the first class, we have discussed about electric current. What is electric current? Electric current is the amount of charge flowing through a particular area in unit time. Or it can be said that it is the rate of flow of electric charges. What is the equation for electric current? I is equal to Q by T, and the unit of electric current is ampere. Okay. In the second class, we are discussed about electric potential. What is electric potential? The electric potential difference between 2 points is the work done to move a unit charge from one point to another. Okay. V is equal to W by Q, that is potential difference is equal to work done by charge. The unit of potential difference is volt. The battery or cell is connected in the electric circuit in order to make a potential difference. Then only the electric current will move or the charge will move. Okay. Then we move on to the next topic, that is symbols of some commonly used components in circuit diagrams. That is, we draw many circuit diagrams. In the previous classes also we draw many circuit diagrams containing battery, electric bulb, ammeter, voltmeter. In order to draw an electric circuit, we have to know the symbols representing these electric components. I will introduce some symbols of the electric components. Okay. The first one is electric cell. We are familiar with the electric cell, that is electric cell is used to make an electric potential difference in the electric circuit. The first one is the electric cell. The symbol of electric cell is this. That is, this is the positive of the electric cell and this is the negative. Okay, clear? Then the battery. Battery, or we can say that it is a combination of electric cell. By seeing the picture, you can clear that it will be a combination of electric cell. That is, the symbol will be, yes, this is positive, and this is the negative of the battery, or we can simply draw it as like this. Okay, this is also correct. This is positive and this is negative. Then the plug key or switch, and the switch is on and off. First, the switch open means it is not connected, that is switch is off. Switch or plug key, we can call it as plug key also. Switch open means it is not connected, that is the current does not flow. Okay. Then the switch closed means it is connected, that is the current will pass through the circuit. This is the switch closed and this is the switch open. Switch open means switch off. Here switch on. This is off and this is switch on. Then the wire joint. Wire joint means wire is connected each other. Two wires are connected. That is, the symbol of wire joint is like this. That is, suppose this is a wire and this wire is connected like this. Okay, this is wire joint. The next one is wire crossing without join. the wires crossing without joining. Here wire joined, the two wires are joined. Here only the crossing of wires without joining. How is the symbol? That is like this. And also this. Suppose these are two wires and these two wires are joined. Then wire crossing without join means it is like this. Okay, clear? Then the next one, electric bulb. You are familiar with the symbol of electric bulb. This is the symbol of electric bulb. Then the resistor. Another component is the resistor. Resistor of resistance R. We will learn about resistor and resistance later. Here we need to study only the symbol, that is resistor. Resistor having resistance R. That is, the symbol of resistor is this one. This is the symbol of resistance having R resistance. Okay. Then variable resistance or rheostat. Rheostat. The symbol of rheostat is same as that of resistor, but small change is there, that is there will be a arrow mark. Okay. Or we can draw it like this. Resistor, then the arrow mark like this. Okay. These two are the symbols of rheostat. The next one, ammeter. We are familiar with the ammeter. Ammeter is used to measure the amount of current. Amount of current passing through a electric circuit. The symbol of ammeter is like this. Positive, negative. Then voltmeter. Voltmeter is used to measure the electric potential passing through a electric circuit, that is V. This is plus and this is minus. This is positive and negative. So these are the symbols of some commonly used components. The first one, electric cell, the symbol of electric cell. Then battery, the symbol of battery, and switch open and closed. Then wire joint, wires crossing without join. Okay, electric bulb. Then resistor, resistor of resistance R. Rheostat, it gives an ammeter and voltmeter. Okay, clear? Then we move on to the next topic, that is very important, that is Ohm's law. Ohm's law. We have studied about electric current and electric potential difference, and there is a relationship between this electric current and electric potential difference. This Ohm's law gives the relationship between electric current flowing through an electric circuit and the potential difference across the terminal. How is it related, the electric current and potential difference? What is Ohm's law states? Ohm's law states that the potential difference V is directly proportional to the electric current. That is, the potential V across the ends of given metallic wire in an electric circuit is directly proportional to the current flowing through it. What is meant by directly proportional? Directly proportional means as potential difference V increases, the current also increases. As the potential difference decreases, the current also decreases. Okay, that is Ohm's law. But that is potential difference is directly proportional to the current. Directly proportional means as the potential difference increases, the current increases. As the potential difference decreases, the current decreases. But in an electric circuit, as potential difference increases, the current increases, and the potential difference decreases, the current decreases only at one condition. It does not happen all the time. It happens only at one condition. And what is that condition? That is at a constant temperature. It is very important, at a constant temperature. That is V proportional to I at a constant temperature. Then what is Ohm's law? At a constant temperature, the potential difference V is directly proportional to the current flowing I. Okay? That is, the potential V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it only at a constant temperature. This is called Ohm's law. It is very important. That is V proportional to I. According to Ohm's law, the potential V is directly proportional to current at a constant temperature. This is called Ohm's law. We can write it as equal to sign, that is V equal to a constant into I. That is, in order to change the proportionality into equal to sign, we have to multiply this quantity with a constant. Okay, so V is equal to a constant into I. We can write it as V by I is equal to a constant. V by I is equal to a constant. And here this constant is very important. Here the constant can be written as V by I is equal to R. That is, this R is a constant and this R is called resistance. Ohm's law states that the potential difference is directly proportional to current at a constant temperature. When the temperature does not changes, the temperature does not vary, the potential difference always proportional to the current. That is V equal to, in order to change the proportionality constant into equal to sign, V equal to a constant into I. V by I is equal to a constant and we given the constant as R. That is, this constant R is called resistance. This equation can be written as V equal to IR. Here V is the potential difference, I is the current and R is the resistance. In an electric circuit, there is resistance. Then what is resistance? That is, we can say that resistance is the property of a conductor. Resistance is the property of a conductor to resist the flow of charges. Resist the flow of charges. So my question is, when the resistance resists the flow of charges or block the flow of charges, the resistance block or resist the flow of charges in an electric circuit, it has a resistance of 10 or 15 ohm, then 10 or 15 resistance, then it has the flow of charges will decrease. When an electric circuit has a resistance, then the flow of charges through the circuit will be blocked. That is, the flow of charges get decreases. Then the flow of electric current also decreases. So we can say that as the resistance increases, the current decreases. Okay, the resistance is the property of a conductor to resist the flow of charges. It resists the flow of charges. The flow, we know, or block the flow of charges. We know the flow of charges is the electric current. So when there is resistance, the flow of charges decreases, hence the current decreases. So the resistance increases, the current decreases. Okay, clear? This is resistance. Hope you understand the concept of resistance. This resistance is the property of a conductor to resist the flow of charges through it. Like electric current and electric potential, this resistance also a property in an electric circuit. The resistance is a property to resist the flow of charges. Okay, the SI unit of resistance is ohm. The SI unit of resistance is ohm. Okay, clear? The symbol is this. We know the equation of resistance. What is the equation of resistance from Ohm's law? V equal to IR. Okay, then R is equal to V by I. I into gets division, that is V by I. This is the equation for resistance. Okay. We already said that the unit of resistance is ohm. Then 1 kilo ohm. 1 kilo ohm is equal to 10 raised to 3 ohm. Okay. 10 raised to 3 ohm. 1 milli ohm is equal to 10 raised to minus 3 ohm. That is, milli means 1 by 1000. Kilo means 1000. Okay. Clear? Of SI unit of resistance is ohm. Then how can we define 1 ohm? Define 1 ohm or define unit of resistance. And from the equation itself we will get, that is, we have the equation of resistance R equal to V by I. In order to get 1 ohm here, the numerator and denominator will be 1. That is, the potential difference will be 1 volt and the electric current will be 1 ampere. Therefore, 1 ohm is equal to 1 volt by 1 ampere. How can we define it? This is only an equation. How can we define it? If the potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance R will be 1 ohm. Okay, clear? Hope you clear that 1 ohm is equal to 1 volt by 1 ampere. We started from Ohm's law. Ohm's law states that the potential difference V is directly proportional to the current flowing I at constant temperature. So, we have to draw the graph of Ohm's law. How can we draw the graph of Ohm's law? Graph of Ohm's law. How can we draw it? The graph will have two axes. Here we know the Ohm's law is the relationship between the current and the voltage or potential difference. That is the current. We take current here, current unit ampere, and we take the potential difference here, potential difference V. It is here 0. According to Ohm's law, the potential difference is directly proportional to the current flowing through it at a constant temperature. That is, as potential difference increases, the current also increases. That is, as potential difference increases, the current also increases. So, the graph of Ohm's law will be a straight line. The graph of Ohm's law will be a straight line. It is very important. The graph of Ohm's law will be a straight line. Since it is a relationship between potential difference and current, it is called VI graph. What is VI graph? The VI graph is a straight line. Okay. This straight line shows that as the current through a wire increases, the potential difference also increases linearly. That is straight line. Okay, clear? In the previous class, we said that in order to make a electric potential, we connect the battery with the electric circuit. Am I right? We connect the battery with the electric circuit to create a electric potential. So, in order to create a resistance in the electric circuit, we uses the resistor and rheostat. We already said it in the components, symbols of components, that is resistor. We uses resistor and rheostat. Resistor and rheostat, mainly the resistor. Okay, mainly the resistor is used to bring the resistance in the electric circuit. Okay, that is, resistor is a component having constant resistance. When we connect, that is, for example, this is a electric cell, this is the electric bulb. I connect the resistor. The symbol of resistor is this. I connect the resistor like this. Okay, the current will flow through it. Okay, there is another circuit. The resistor with resistance R is connected. The resistor with the resistance R is connected in this electric circuit, and also I connect a bulb without resistor. Here also current I will be flow. Here I current is flows through it. But here the current I will not flow fully through it because of the resistance. What is the purpose of resistance? We already said that resistance is a property that blocks the flow of charges. That is, it decreases the flow of current. That is, here the flow of current is very less than this case. In this case, there will be less current flowing through this circuit. In this case, more current. The resistor will resist the flow of charges and decrease the flow of charges or decrease the amount of current. That is, here I will be less. I hope you clear that. Resistor is connected. Resistor is a component having constant resistance. Okay. Resistor is a component having constant resistance. Constant resistance. Resistor symbol is like this. In rheostat, there will be variable resistance. In rheostat, there will be variable resistance. Variable resistance means the resistance can be changed, increased or decreased. The resistance can be increased. Here the resistance can be increased or decreased. Here only a constant resistance. When a resistor is connected, it has a constant resistance. It cannot be changed. Suppose when I connect a resistor in an electric circuit, the resistor has a fixed resistance. It may be 4 ohm, 5 ohm. But in the case of rheostat, the symbol of rheostat is like this. That is, in the case of rheostat, the resistance can be changed. When I connect a rheostat in an electric circuit, that resistance can be changed to 4 ohm, 2 ohm, 3 ohm, like that. Okay, clear? Hope you clear the difference between resistor and rheostat. I already said that as the resistance increases, the current decreases. As the resistance increases, the current flowing through the circuit will decreases. Okay, clear? As the resistance increases, the current flowing through the circuit decreases. So, when we connect the resistor use many wires as resistor. That is, in case of conductors conduct electricity more. So, in conductors, the resistance will be very low. The resistance will be very low in case of conductors. And in case of poor conductors, we know the poor conductors conduct electricity or conduct electric current less. So, the resistance will be high. Okay. Then in case of insulators, the resistance will be very high. Insulators do not conduct electricity or do not conduct electric current. So, the resistance will be very high in case of insulators. Hope you understand the differences. Okay, clear? Here we discussed about Ohm's law. Today we discussed about Ohm's law. What is Ohm's law? The potential difference is directly proportional to the current flowing through it at a constant temperature. That is V proportional to I. V equal to IR. R is a constant. R is called resistance. Resistance is the property of a conductor to resist the flow of charges. SI unit of resistance is ohm. What is resistor and rheostat? Resistor is a component having constant resistance and rheostat is a device used to change the resistance in the circuit. Okay, clear? As the current increases, the resistance decreases. Okay, hope you clear that. We will continue in the next class. We will do the problems relating to this topic. Thank you.